busy with trigonometry. Today we have a mixed exercise. So now we must make sure that we understand everything about trigonometry. Let's just revise what we know at this stage. When we work in a right-angled triangle, this is opposite, hypotenuse, and adjacent. This is a right-angled triangle. There we have the three functions. Sine theta, which is opposite over hypotenuse, cosine theta, which is adjacent over hypotenuse, and tan theta, which is opposite over adjacent. How will I know which one to choose? Remember here, if this is your opposite and your hypotenuse. For cosine, it's that included angle, cosine. And when we work with tan, you have opposite and adjacent, no hypotenuse is involved. We ask ourselves two questions: which function, which method? Then we've learned now about any triangle, So if this is triangle ABC, the first important thing was that the sides have the small letters opposite the angle, have the small letter. And now we've learned four formulas here. The first one is the sine rule, which says A over sine A is equal to B over sine B. The second one is the cosine rule. A squared is equal to B squared plus C squared minus, in brackets, 2BC cosine A. This angle and this side must correlate. Then we can also find the angle. That's when you have the three sides. And it is then B squared plus C squared minus A squared, the one opposite the angle, over 2BC. And the last rule that we learned is the area of any triangle, which is half BC sine A. And again, this will be two sides and the included angle that we will use for that. So we're looking now at exercise 9.1 on page 477. And this is now a revision exercise. So we must decide which one of all those formulas are we going to use. So we've got the picture there. In the triangle ABC, it is a right-angle triangle. Calculate the length of AB. Now we know finding that third side is then always Pythagoras. So it will be 17 squared minus 15 squared. If you press it with those brackets there, you immediately get the answer of 8. You must first do this exercise now and then mark it. The next one, number B, it's a right angle triangle. Use trigonometry, calculate angle C. Now actually we've got all three sides, so you could use any one, but you must choose the correct one. So I've chosen cosine. So cosine C is adjacent over hypotenuse. How do we get angles? Which method? Second function, cosine, and C is then 28.1 degrees. Angles rounded to 1 decimal place. Number 2. Now, that number 2 is actually showing you Pythagoras because it's that theorem of Pythagoras that we have there. So we can say that 625, now remember this is the area. And so we can get the square root of that one, and then the square root of 400. So if we subtract those two, you will get F, which is 15. So they actually gave you those squares already. Number 3. Again, we've got a right angle triangle there. Explain why A in C is right angled. Now we do that by using Pythagoras. We must show that Pythagoras is working. That's how we can show that it's a right angle triangle. So this is 169, which is 144 plus 25. And then we get that 169 is equal to 169. So Pythagoras is working. We test it. Number B, now they say, give your answer as a fraction. So they do not want the angle. They just want the ratio. So in this case, we must choose the correct sides every time. 12, 5, and 13. Now, they want cosine A. This is angle A, cosine A. So the question is, which two sides will it be? Included angle. So it is 12 over 13. That's all that they want on that one. And then the next one, sine C. Now this is angle C. And sine C is then also going to be 12 over 13. So you can see, if we use those opposite angles, then sine and cosine will be equal there. Question 4. Now, here we've got 3 right-angled triangles, so we'll have to look very carefully there in which one we are working, but it is still right-angled triangles. This angle here is 37, that side 550, 420, and 56. Now, the first thing that we want to find now here is AB. AB. And we've got the two sides there. This is what we want to calculate. So it will be 550 squared minus 420 squared. And the answer that I got there was 355. You can just do the sum. Number B. Now we want BC. So now this is what we want to calculate, BC. Which function will you use? And I would say it is the tan function. Can you see the hypotenuse is not involved? So tan 56 is equal to opposite over 420. Which method do we use? Top times. So we will just multiply there, and it is then tan 623 meters that we will have there. The last one, number C, is to calculate DE. Now we're here. This is what we want to calculate. Which function will we use? Cosine. It's the included angle. So cosine 37 is equal to 550 over ED. And which method this time? Bottom divide. So it is 550 divided by cosine 37, and it is then, my answer is 689 meters. 698 meters. The next one, question 5. So you have that boat. Now, this sum is an interesting one because you have a right angle triangle here and any triangle there. This angle is 18 degrees, 44 degrees, 30, and 80 here. So the angle of elevation is 18 degrees. There we have that one there. Give your answer to 1 decimal place. Now, in the first place, we have to calculate now AH, which is this side that you want to calculate. So which function, which rule are we going to apply? Because this is any triangle. It's not a right angle triangle. And we can work with opposite sides. So it will be sine, but you will need this angle because this angle is opposite the 80, not this one. So this is exterior angle, which is equal to the sum of the opposite angles. So this little angle here will be 26 degrees. It's important to get that first. So I'm going to use the sine rule, opposite sides, opposite angles. The one that I want to find comes on the left-hand top. So it is now AH. Now then I actually need AH over sine, and now we need, this is actually the angle that we need here, is that one. So it is then 180 minus 44, which is 136. So I need 136. I need the opposite side, and the opposite angle there is equal to 80 over sine 26. So can you see I need two angles in there to do that one. So we cross multiply here, and the answer is 97.1 meters. Number B, calculate the distance BH, the distance BH. Now BH is now this side here that we need to calculate. Now I can work in the right angle triangle there, and I can again use the sine function. So sine 44 degrees is equal to 30. This is now a right angle triangle over BH. Which method? Bottom divide. So it's 30 divided by sine 44. And this one's answer is then 43.2 meters. 43.2 meters. Question C. Hence calculate the distance BC from the foot of the cliff. Again, there's more than one possibility. I will use tan. So tan 44 is equal to 30 over BC. Which method? Bottom divide. It will again be a division one, which is then 31.1. But the question is now actually, hence calculate the distance BC from B to the foot of the cliff. So that's actually that whole distance. Well, if you want to find AC now, it will then 80 plus this 31.1, which is 111.1 meters. Right, grade 11. So now you can do the second part, which is now a little bit more difficult. We're continuing our lessons on trigonometry, and today we're specifically looking at bearings. Now there's three things that we need to know about bearings. The first thing is we always work with a north line, and the direction is north clockwise. You work north clockwise. So this is the direction that we're going to measure. The next important thing is you're looking at the from angle. If I say A from B or B from A, then it will be this angle here. From, that's where you should look at. Another thing is that at B we can draw a second north line, and those two lines are now parallel. So here you have co-interior angles. And then we give it as a three-figure bearing. A three-figure bearing. So that means, for instance, this one is 125 degrees. That's the bearing. If there's no zero there, or if it's a smaller number, then we use a zero in front for bearings. Okay. So we're looking now at try now 38. and this is on page 481, page 481. So you have to find the bearings B from A. So we're looking at the A angle there. Now the first ones are very easy. If you look at that one, it's a straight line. North clockwise will be 145 degrees. I get that, 180 minus the 35. Number B, so we have an angle like this. So this is a straight line which it's 180 degrees, and then we add this little angle here. So this one is 220 degrees. Number C, obviously that's just that 039. Look at the 3-figure bearing that we're using then here. Number D. So there it looks like this, and the only thing that you have is that this one is 250 degrees, 25 degrees. We know up to there is 270 degrees if we go north clockwise. So 270 minus the 25. So this bearing here is then 245 degrees. Number E, that one will be 360 minus the 53. So it's 307 degrees. I can also work with that 360 degrees there. And number F is then 270 plus the 47, which gives me 317 degrees there for that one then there. So that's just bearings north clockwise that we're looking at. The next one is now try now 39. Again they say find the bearing of A from B. So we're looking at B. So this one is now 35. This is A, this is B. So what we're looking at is this angle. That's the bearing north clockwise there. So what we can do here, what we know, is that this angle, this is then co-interior angles because these two lines are parallel. So it means that this angle here, this one here, will be 145 degrees. And then we can say 180 plus 145, which is 325 degrees then for that one, number A. Number B, there's the north line. This time B lies here. There is A. We know that this angle is 45 degrees. Remember, we want A from B. So what we actually want is this angle here, from B, north clockwise, alternating angles because of the parallel lines there, and it is then 045 degrees. 045 degrees. Number C. There's my B. This one is 39 degrees. So what do I want? This is the bearing that I want there. So you can add the reason that this one, little one, is also 39 here, alternating, or you can find that one then there. So if I say 180 plus 39, then I have 219 degrees there, 219 degrees. Number D. So this one looks like this. Here we have this triangle, and point B is here. So this is the second north line that we have. This one is 65 degrees. Again, A from B. So this is what we want. There it is. And this one is alternating with this one. So it is 065 degrees there. Number E. There is A. Here is B. I draw the north line there. We know that this one is 53. So A from B. So the angle that I want to find is this one here. Co-interior 180 minus that one, and that is then 127 degrees. And the next one, number F. So we know that this angle here is 43 degrees. There is B. I draw a north line there at B. Again, my two lines will be parallel. So this is co-interior angles, and it will then be 137 degrees. So that's the basic things on bearings that we have there. So now we're looking at try now 40. Try now 40. And now we've got word sums, and it will always be good to draw a picture here to see what you have. A map shows 3 towns, D, E, and F. D is due north of F, so there's F, there's D, and E is due east of D. Now, that due east means a 90 degrees, directly east, directly north, that we're going there. So DF is 75, and the bearing of F from E. Now, the bearing of F from E is now this angle there, and that one is 245 degrees. And now we have to find D, find the distance DE, the distance DE. So this is what we have to calculate here. Now, we can find the size of this angle, and then that one alternates with this one, or then we can get that one because we need an angle inside the triangle. So to get this one, it will be 245 minus 180, that straight line there, and that is 65. So this one and this one is then 65 degrees. Now we have to calculate DE. I will use the tan function here. So tan theta is, or tan, we can actually say tan 65 degrees. We have theta is equal to DE over 75. Which method do we use? Top times, because this is a right angle triangle, and the answer will then be 161 meters. And then in the second place, B, they want EF. Now we have to calculate this one. We can work with a Pythagoras perhaps to find that side there. So EF. So EF is then equal to 75 squared plus 161 squared. I want the hypotenuse, that's why I add, and my answer is 178 meters, 178 meters. The next one, number 2. Now there you have a picture looking like that. Now let's redraw it. It's not a right angle triangle there. It looks like this, and then they formed right angle triangles everywhere there so that we can see what's going on there. So this one is 64 degrees, this one 58, this one 42.3, that is the vertical distance there, and this one 15.4. Right, so the first question now here is, the ship leaves Port P on a bearing of 64 degrees. It sails for 58 kilometers to A, and then calculate how far is A north of P. Now you can see, now they say find PH. That's why they've drawn that right angle triangle there. Which function will we use? Cosine. It's that included angle there. So I can say that cosine 64 is equal to PH over 58. Which method? Top times, that's what we're going to use, and it is 25.4. Make sure that you first do the exercises before you mark them. Then A2. Now east of P, and now they say we have to calculate HA. So now we're looking for this. This is what we're looking, but we're still working in this right angle triangle there. Can you see? So this time I will use, well, you can use Pythagoras, or you can use sine, we can use any one there. So AH is then equal to 58 squared minus 25.4 squared. And that gives us, as I say, you might use another function as well there. And it gives you 52.1 meters, 52.1 meters. Right, now B of that question. The ship then sails to the island B. So if we look on our picture, it now sails here to B, which is 5.3 kilometers south of A and 15.4. So now we have this right angle triangle there. And now they say, calculate BAJ. BAJ, so we work in this right angle triangle. We're going to use tan there. So tan A is then equal to 15.4 over 42.3. And it's an angle that you want, so it will be second function tan A is equal to 20 degrees. 20 degrees. And the next one. Now, number 2 there, the bearing of B from A. The bearing of B from A, now if we go back to the sketch, this is the angle what we want now. We know that that is 180, and we have this size of this one to be 20 degrees, so we can just add the two, and that will then be 200 degrees. Now we look at number C. Angle KPB is 65 degrees, and we have to calculate the bearing of P from B. P from B. Now again, if we go back to our sketch, P from B means this is the angle that we want there. That is what we want to calculate there. Remember your north lines, that you work with your north lines, and that bearing is then 295 degrees, 295 degrees. Right, and we continue with number 3. The ship leaves Port B and sails 5 kilometers on a bearing of 120 degrees. Find the bearing of P from Q. So now we're working there. The easiest one will be to say that this angle now there is 60 degrees, and this is then 360 minus that 60, which is 300 degrees. 300 degrees. And then how far Q is east of P. Now Q east of P is, this is the line that we want to calculate there. So you can do different calculations. We know this one is 60 degrees. We can see here that this angle is 30 degrees then there as well. And we can use the sine function here to calculate that due east of P with sine then there. Let's say sine 30 degrees, no, sine 60 degrees is equal to x over 5, the hypotenuse there. Which method? Top times, and my answer is 150 meters. 150 meters. Question 4. A building B is 300 meters from S. Building B is 300 meters from S on a bearing of, oh no, let's redraw this one. Okay, on a bearing of 240 degrees. So the bearing there, 240 degrees will be like that. There is the 240 degrees. The building B is 300 meters from station S. So this is S, and this is B, and this one is then 300 meters. A spot T is due south of S. So if we go down there, there is T, and due east of B. So there is the 90 degrees, the due. Due means directly to that one there. Now we want to find ST. We need to find ST there. This one is 180 degrees, which makes this angle here 60 degrees. And then to find ST, which function will you use? Cosine here. So cosine 60 is equal to ST over the hypotenuse of 300. You need a sketch to be able to do this. And this is then which method? Top times, and it will be 150 meters. 150 meters. Question 5. 3 points are on level ground so that B is due north of A. I will start here with A, and there is B due north of A. The bearing of C from A, the bearing of C, no, it's an obtuse angle. The bearing of C from A is 46 degrees, so there's C. And the bearing of C from B, there is 125 degrees. So that one is 125 degrees then there. If the distance between A and B is 200 meters, there's the 200 meters. Calculate the distance C from A. So this is what we want to calculate here. This is now not a right angle triangle here. I can find out B, which is 55 degrees there. I can find that one there. And then I can also find C. So I first need to find C now there, which is then 79 degrees. It's in the triangle, so I can just calculate that. And now I will use the sine rule here, and I will say AC over sine 55 is equal to 200 over sine 79. Remember, opposite sides, opposite angles, that is what you need. And if we do the calculation now here, AC is equal to 167 meters. AC is then 167 meters. Right, the last exercise is now try now 41 that we're going to do here. Try now 41. So these are nice mixed exercises that we're looking at now here. Try now 41. So you have the picture there, number 1. L, B, and R. Now the first one is calculate a LR, this length here. We have the two sides, and you want that third side there, 0.75, and this one is 110 degrees there. You want the third side, and that is always the cosine rule. So LR squared is now 1.2 squared plus 0.75 squared minus in brackets 2 times 1.5 times 0.75 cosine 110 degrees. It's very important that you first do the exercises before you mark them. Then we do that calculation, you get the square root there, and my answer is 1618. They say round it correct to the nearest meter, so that's why we round off like that in this case. The next one, number 2. So now they say the bearing of angle BLR. So now we want to find this angle here. So in this case, I will use the sine rule because I have opposite sides and opposite angles. So sine L is then equal to, or sine L over that side of sine 0.75 is equal to sine 110 degrees over, and now we have to use this one, but you actually have to use the unrounded one that you have here. The unrounded one, not the rounded one, because otherwise your final answer will be wrong. And then second function sine, this is how we will do it, and my answer there is 26 degrees. 26 degrees. Now at number B, they asked the bearing of L from R, or L from B. L from B means this is what I need there, L from B, L from B. So if this angle we found now is 26 degrees, then this angle and this one will be alternating. So I can find that little angle there to be able to calculate that bearing then there. Because you need to find that north clockwise bearing then there. So at number B, the bearing is then 223 degrees. 223 degrees. The second one is B from R. B from R, so now we want, no, B from R is here. So this is the angle that we want then there. So you can find this angle because we've got those two. So we can find this angle, and then you can either work with 180 plus these angles or 360 minus that one at the top there, and the bearing is then 303 degrees. Remember, your north lines are parallel, and then you always have those alternating angles or co-interior angles. And then at C, it says now, the boat is sailing due south. The bearing of B from R. Perhaps I can just explain it here a little bit more. I wonder if you understand now. So I can say it's 180 minus the 123. Then we get that angle there is 57 degrees, that little one there at the top. And then 360 minus the 57, and this is how I got that 303 degrees there. So just look again there. Can you see? Because then you can find those angles then there. This one is then 123 degrees. And that's how I get that top one there. Now number C, the boat is sailing due south. So this is now from here that it's sailing due south, and calculate to the nearest, the closest distance to the lighthouse. So if it sails due south here, this is where we will get the closest distance there. You draw a line directly there, and because it's due east, you have a 90-degree triangle then there again. So we have a little triangle looking like this then here. The closest distance to the lighthouse. So we can use sine then there. Right, so let's look here. This is then from the boat. This is the due south. There's the lighthouse. We know that this one is 1.2, and we've already calculated this angle to be 53 degrees. So we can say that sine 53 is then equal to x over 1.2. And then which method? We want that distance there, top times, and my answer is 958 meters then there, 958 meters. Right, question 2. So we have a north line there, and this one here. So this is 40 meters, 32 degrees, 53 degrees, 70, and 45 meters. That's what we have now there. It's a hockey match player, and this is how they run playing the hockey game. Show by calculation that BAC is 37 degrees. We have to show it. We've got 3 sides here, so you're going to use the cosine rule. So I can say that cosine A is equal to, now remember, this is the one that you're going to subtract, so it will be 40 squared plus 70 squared minus the one opposite, that is the one that we subtract, over 2BC 40 times 70, and second function cosine, and then you get that value of 37 degrees. It's a show that question, so you must go through all the steps there to show that. Now they say the bearing of C from A, the bearing of C from A is 51, so that whole angle there is 51 degrees. Now we need to find the bearing of B from A. Here is B, so what you actually want is this little angle here. This one is 51, the whole one. That one is 37. So the answer is then 51, so that is 14 degrees. We just subtract the two then there from each other. Okay, and then they say at number 3, calculate the area of ABC. Now we know that this is half BC sine A. Remember, 2 sides and the included angle. So it will then be a half of 70 times 40 sine, and that angle there is 37 degrees. Just need to know our formula, and it's 843 square meters. That is that area that we have there. And then the last one is number B. Another player is standing at D at the top. Let's just get the picture again. Is standing here at D at the top there. BC is 45, and that angle is 54 degrees. And now they say, and this one 32, calculate the length of BD, the length of BD. So which function will we use? We can use the sine rule, opposite sides, opposite angles. And it will then be BD over sine 54, which is equal to 45 over, and you just have to calculate that third angle because it's opposite sides and opposite angles, and then the length of BD is equal to 36.5 meters. 36.5 meters. Right, thank you, grade 11.
Akili, 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 akili.
We love to wash our hands, and this is how we do it. Wash, wash with clean water. Scrub, scrub, scrub with soap. Rinse, rinse with clean water, and then the germs will go. We love to wash our hands, and this is how we do it. Wash, wash with clean water. Scrub, scrub, scrub with soap. Rinse, rinse with clean water, and then the germs will go. Yay!
Well done, soap and water. You got rid of all the germs on Achilles' hands.
are marking then exercise 9.2. So now we have revision exercises of bearings and trigonometry. Do the exercises first before you mark them. It doesn't help if you just listen to the recordings. You have to do and try it first. Right, so there's the sketch of the first one. They say here the bearing of B from A is 72 degrees. So that will be that angle then there. And now we have to find the bearing of A from B. Now A from B means this is the angle that we are looking at there, north clockwise, north clockwise. What we know here is that this is so important, your north lines are parallel. So here I have two alternating angles, which makes that angle then there 72 degrees there, 72 degrees. So at B. It is an isosceles triangle that you have there. We have to calculate now the bearing of A from B, from A from B. So you can work like this. The other method that we can follow here is to find this angle here, which is then 180 minus 72. 180 minus 72. 180 minus 72, and that is 108 degrees. So this one here is 108 degrees. And then we can just say 360 minus 108 degree there, and that is then 252. So that is the bearing of A from B. And then the next one is, they say C is due south, my picture is not precisely there, of B, that means directly south there, and we have this isosceles triangle. Find the bearing of A from C. Now, this is what we want to find now here, A from C. So we can find these two angles because they will be equal there. So they are 54 each, 54. And then we can say 360 minus this 54 here, 360 minus 54, and the answer then, the bearing of A from C is 306 degrees. 306 degrees. Right, the next one is question 2. We have three towns, A, B, C. The bearing is 132 degrees there, and they give us that BAC is 75. Now, the first thing that we have to find now here is ACB. ACB. Again, there's different methods to calculate it. It's again an isosceles triangle that we have here, which means then that, okay, let's first work with the north lines here. And we can then say that this angle here is 48 degrees. Can you see? 48 degrees, those co-interior angles. We can also find this angle here to be 153 degrees because they will add up there to 360 degrees then there. So now in the first place, we have to find C here. So it means this one will also be 75 because it's isosceles. And then this angle here is then 30 degrees, 30 degrees. The next one is the reflex angle ACB. So that's just 360 minus the 30, which is 330 degrees, the reflex angle. Then number B, the bearing of A from C. A from C will be this angle. That is what we need to calculate. Now, we already said that one is 48. 360 minus 48 will give you that angle of 312 degrees then there. And then the last one, A from B. Now, A from B means this angle here that we have to calculate. No, sorry, that one, it won't be that one. It will be this one here that we need to find there. A from B. A from B. And if this one is 153 here, this is again parallel lines, then I can just subtract it from 180, and the answer is then 27 degrees. 27 degrees. Right, question 3. So we have Auckland, Hamilton, Tauranga, and Rotorua. We are now in New Zealand here. Calculate angle HAT. Angle HAT. So HAT means this is the one that we need to calculate here. Let's just look at our information. And we can use the cosine rule here to find that angle then there. We also have the third side here. That was what I was looking for. So I can say that cosine A is then equal to 180 squared plus 115 squared minus 90 squared. It's 90 squared. It's so important. The one opposite the angle is the one that we subtract over 2 times 180 times 115. And that gives us A is then equal to 25 degrees for that one. Okay. Then we want at B the bearing of T from A. The bearing of T from A. So this is now what we are looking at. T from A, so it is that angle that we want to calculate there. There will be another north line there. Okay, and that one will then be the 150 degrees minus 25. We found now that this angle here is 25 degrees. So it is then 150 minus the 25, which gives us 125 degrees. So that bearing there is 125 degrees there. Then A from T. A from T means this is the one that we want to calculate now there. So the best thing would be to get that little angle there. And if this one is 125, then we can calculate this one to be 55. Your north lines are parallel. Can you see how many times we come back to that? So 180 minus the 125 now is 55 degrees. 55 degrees. Then we come to C. Calculate how far T is east of A. Now here we'll actually have to draw a further sketch because that is where the east lie. That east part that you want to calculate now is here. That's what we want to find now there. East of A. So angle THR is 30 degrees. Sorry, number C. Calculate how far T is east of A. So I'm going to use cosine there. Cosine 35 is equal to AE. That is that east distance now over 180. Which method? Top times. And we can say then that AE is equal to 147.44. Remember we said first round down the unrounded one and then you round off in a final step. So now we're looking at D. Angle THR, this is now the small triangle here that we are working with there. THR is 30 and this one is 70. Calculate the distance TR. So I will use the sine rule there. The sine rule there. And I can say that TR over, which one is now opposite? Sine 30 is equal to, now we've got that side of 90 over sine 70. That is what you will use there. Cross multiplication, we can then say that TR is equal to 47.9 meters. 47.9 meters. And the last question is now about a scale there. they say 4.5, and this is now equal to 90 kilometers. So we have to change kilometers to centimeters. And you do that, there is 50 centimeters in a kilometer. But I would also like to remove this one. So I'm going to multiply with 6 zeros. So you have 45 to, and then 1, 2, 3, 4, 5, 6 zeros. And the ratio then here is 1 to 2 million. Changing that ratio. Right, thank you, grade 11s.
Wash away the germs. Akili and Happy Hippo have come to play with Little Lion. Little Lion doesn't want to play. He's afraid of germs. Germs can make you sick. Don't worry, Little Lion. We will get rid of the bad germs and then you can play with us. They hunt for germs high and low, inside and outside. But the germs are nowhere to be found. What are you looking for? Asked Miss Shrub. We're looking for germs, says Akili. Germs? Germs are everywhere. They are so tiny that you can't see them with your eyes. When you touch something dirty, germs hide on your hands. With water and soap, you can get rid of the germs and make your hands clean. You must wash both sides of your hands, under your nails, and between your fingers. We will wash away the germs and make your hands clean. Akili, get fresh water. Happy Hippo, get soap. Wash, wash, wash with water. Scrub, scrub, scrub with soap. Rinse, rinse, rinse with water, and the germs will be gone. Akili and Happy Hippo run to tell Little Lion that they found a way to get rid of the germs. After we go to the toilet, after we sneeze, when we cook, and before we eat, we wash, wash, wash with water. We scrub, scrub, scrub with soap. We rinse, rinse, rinse with water. And the germs will be gone. Now we can play all day because we know how to keep the germs away. After all that playing, it's time for cake and tea. But remember to always